Okay, this is a quick video to show off some of the features of the 960 sequential controller by Behringer. So I'm going to start off with a sort of simple patch. We're going to take the output of the sequencer, just an output there from the first row. One of the things I'm not going to do is I'm not going to be showing how to do multiple rows, because that's lots of videos showing how to do that. So I'm showing more some of the unusual things. So that's going to go into our oscillator. I'm using a 921, so it's nice and simple for seeing what's going on. I take the output of the oscillator, I'm going to put that into the filter. I'm going to take the output of the filter and slightly longer lead for this. I'm going to stick that into voltage controlled amplifier, and then what I'm going to do is I'm going to take the output from the oscillator. This is the oscillator output, which is a clock. I'm going to put that to an input. So let's do it to here. So that's going into my interface, which will give me an S trigger out. And the S trigger out will go to the input of my envelope generator. And then the envelope generator output can go to my voltage controlled amplifier. So now very, very simple layout. I've got, let's start it. Well, new thing, let's turn up. Right, so I'm not really worried about the musicality of the sequence. It's more to show what's going on. So the sequence runs from 1 to 8 inclusive, and with most sequencers you can take an output, for example from the 7th step, and you can plug it into the 2nd step, and what you would expect is it from then to run from 2 to 7, but it doesn't. It runs from 1 to 6. Let's move that, and we see it makes no difference whatsoever. And so for a lot of people, this is one of the criticisms of the sequential controller. However, there is a get around. So we take the output from, it's actually the end of 6 rather than the end of 7. So always the output is at the end of the previous stage. So this is actually the output from the end of 6. So I'm going to take that over to column B in my interface. I can stick it in anywhere in there. And that then gives me an S trigger out. So I can just go to the S trigger out. I'm going to plug it into the S trigger in on the interface, because I need to. So what I'm doing is I'm taking this pulse, I'm putting in column B, I'm stretching it very slightly, I'm taking the output and converting it back to a V trigger. So now if I put it in, we can see that we're now going between 2 and 6, or we can go between 3 and 6. So although lots of people say you can't do this, you can. When Bob Moog designed it, of course he was an electronics engineer, and he was thinking in terms of maximum flexibility from the engineering perspective. Let's just going to turn it down a little bit. Right, so next thing I'm going to do is I'm going to make the sequence a little bit longer, and I'm going to look at the sequential switch, but rather than using it to switch between the different rows of the sequencer, we're going to use it to add an additional voltage to the signal to give us a transpose. So how we do this is by taking, we can take an attenuator input, we'll put this into 2, we can take the output and we're going to put it into the oscillator, because they will add at the oscillator. The inputs are summing inputs, so that's adding the two things together. And I need a voltage, so I'm going to take my positive +6 volts rail and put that at the input, the attenuator. Now I need to make this shift. Now I can choose where I do that by just picking a point where I want it to shift. So let's just take this output here, and we're going to put this into the shift, and we can hear that if I turn. And so you can hear now we're using this to transpose, and we can change how much we transpose it by. Of course, you choose. I'm choosing the different transpose points with. So there's some interesting things you can do with that sequential switch. Now, one other thing that's possible is that we can actually use the control input of the sequencer. Instead of providing it with a typical straightforward voltage, we can then take one of our signals, S triggers, and we can then trigger an envelope generator, so we can change the timing of the sequence. So here I'm going to put a control input in. I'm going to take it from an envelope generator. Okay, so it doesn't do anything yet, so I need to trigger the envelope generator. So let's just have a look. So this output here, I've got an S trigger there. So take the S trigger, I'm going to put it to multiple. Let's put that back in. So I can now duplicate that S trigger and put it in here. And so you can get some interesting timings, and you change the timing with your envelope generator. So this is really useful for that sort of analog rhythmic effects that you don't get with your sort of normal regular clocks. So you can do some very, very strange stuff with that. Let's unplug that. So that's a sort of a little look at some of the possibilities. Now, one of the other things that's quite interesting is when we stop the sequence, we can click to make it go back to the beginning. I've got here a ulterior key step, and this has got a gate out and a pitch out, and so obviously this is quite an interesting way to control your sequence. So let's take the pitch, and then I'm going to put that in here, and I'm going to take the gate, and I can use the gate, and I'm going to put it in here where it says shift on the sequencer. And so now if I play an arpeggio, you can see the arpeggio is playing, we can't hear anything. So let's just have a look. So one of the reasons why we're not hearing anything is that we no longer have the oscillator output providing us with a gate. So we need to get a gate from somewhere. So maybe a good idea, instead of putting that straight into the shift, we can put it into another multiple, and then we can take that gate and we can put it into the sequencer shift. So I've got both sequences running now from the, and so you can clock from your sequencer. And you can do some really interesting things with setting up sequences of different length and using them to control things like the filters. So that's it. I hope you enjoy the video. 960, absolutely wonderful device, and of course, you just have to remember it's designed really by an engineer, so the masses of built-in flexibility, but not often obvious in terms of patching compared with modern synths. Well, bye for now.